Hello and welcome. In this lesson, we'll explore asymptotes. We are studying the unit of rational functions, and their graphs are shaped by their asymptotes. And in order to determine them, we'll need to understand where they come from. Asymptotes are formed when the domain of a function approaches infinity or the range of a function approaches infinity. So when determining the asymptotes, operations with infinity are involved. So that's why I prepared this short mini lesson on understanding infinity. Infinity, by the way, is not a number. Infinity is a descriptive word or a name that we give to numbers that are very, very, very large. And we call them positive infinity, or very, very, very small. We call them negative infinity. So we're going to take a look at some practice exercises that will help us understand how to add, subtract, multiply, and divide numbers that involve infinity. So first, dividing a number by infinity. So let's take a look at the first example, number 1 divided by infinity. So in order to figure out the answer, I invite you all to think that to imagine that you have $1 and you are sharing it with the rest of the world. Practically, everyone will get $0. Mathematically speaking, everyone will get something very, very small, hard to describe small. And in order to indicate that everyone will get something, we're going to use the symbol plus on top of 0 in the place of the exponent. So in the next exercise, I'm changing from number 1 to number 3, so I'm making the number a little bit bigger. Would the answer be affected by this? Remember, any number compared to infinity is very, very small. Even if we had 3 million in here, then divided by infinity will still be 0. And we're going to say a little bit more than 0 and add the little plus on top of 0 to indicate that. Now, if we have negative 1 divided by infinity, we have a negative number divided by a positive number, so the sign is still in power here. So what I want us to think in this case is, imagine you have a $1 debt and the whole world is helping you pay for it. So everyone will pay something, right? Well, practically nothing, but a little bit less than 0. Okay, so everyone will be in debt or giving a little bit less than $0. So negative 3 divided by infinity, doesn't matter how big or small this number becomes when compared to infinity, is still 0. The sign will be negative because when it comes to the signs in division multiplication, their role remains the same. Negative 1 divided by negative infinity, again, will be 0. It will be 0 plus because two negatives will give a positive. Same idea applies to negative 3 over negative infinity. So the two negatives will make a positive, right? And this will be the same as 3 over infinity or 0 plus. Now let's take a look at another group of exercises, dividing infinity by a number. So imagine you have infinity, an infinity amount of money. Money is easier actually to kind of work with and imagine, and you are sharing it amongst 3 people. Everyone will get infinity. Infinity divided by a negative 3, we have a plus and a minus. It would be negative infinity. Now, can we multiply infinity by a number? Well, let's take a look. So, infinity multiplied by 3, it will make infinity even more infinity. So we'll say the answer is infinity. So here we have a negative with a positive, which means negative infinity. Infinity times a negative number, that would be still infinity, but negative because the signs are plus or minus and minus. So infinity times 3, that would be infinity. The sign will be negative times negative, positive infinity. Now, can we divide by a number very close to 0? Now, what is a number very close to 0? I'm going to draw a number line here. And here is where 0 sits. A number very close to 0 can be close to 0 from the right-hand side. We call this 0 plus. Or it can be a number very close to 0 from the left-hand side. We call it 0 minus. An example of a 0 plus number can be 0.00000. You can add as many zeros as you want because you can get as close as you want to 0. And an example of a 0 minus can be negative 0.0000, and you can add as many zeros as you want again. So imagine that we have number 1 divided by 0 plus. So number 1 divided by, I'm going to write a fancy number here, 0.12345678910. I'll stop here. And if you use the calculator, then the calculator will tell you that this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros, right? So as you can see, the more zeros you add in the decimal in the denominator, the larger this number will become. So as you get closest to 0, then we're going to go towards infinity. So we'll say that 1 divided by 0 plus is infinity. Now, in the next exercise, we have 3, a positive number, divided by 0 minus this time. So think about having number 3 in the numerator, and in the denominator we'll have very close to 0, but in the negative. So negative 0.0000. Let me see how many. 4, 5, 6, 7, 8, 9, 10. So the answer in this case will be a negative because we have division of a positive with a negative. So that means that we have negative infinity. The same idea applies the rest of the exercises. So you see that we have a minus and a plus. That means that the answer will be negative. We have a number divided by 0 plus, negative infinity. Negative 3 divided by 0 minus, we have division of 2 negative numbers. So that will give us a positive. And a number divided by very close to 0 would be infinity. Now, moving on to multiplication and division with infinity. So the question now becomes, can infinity multiply infinity? Think about it. If you have infinity multiplied by an increasingly large number, it's logical to say that we're going to get an extremely large number because it's multiplication, right? Infinity and negative infinity multiplied together will give a negative number, a negative infinity, because we have a minus and a plus. That's where the minus here comes from. Negative infinity multiplied by negative infinity, remember you have a minus and a minus, that will give a plus. And 2 infinities multiplied will give an even bigger number. Now, can we divide infinity by infinity? So let's take a look at this example. Imagine having infinity, dividing it by infinity. We don't know how large an infinity the numerator is and how large an infinity the denominator is. So we are going to say that if this infinity in the numerator had an extra 0, and remember again, infinity cannot be a number. It's not a number, right? It's just a descriptive word used for very, very large numbers, hard to describe how large they are. Then the ratio will be like 10 times bigger, right? For an extra 0. And because it's very hard for us to put a number or a size to the numerator and denominator in order to divide, we're going to say that this is undefined. Or some people like to say it doesn't exist, DNA. And the same thing applies to negative infinity divided by negative infinity. It's undefined, or it doesn't exist. Same idea here, undefined and doesn't exist. And when it comes to asymptotes that are calculated based on these kind of operations, we're going to use a special method actually. It's kind of fun too. Rational functions seem a little bit difficult at first. Once you understand the asymptotes, they become probably the funnest functions to graph. So, I added a few more questions in here, all with the purpose of us understanding how asymptotes are formed. You will see how they will help. What happens when we approach a number from the left and the right side of it? So very often when we determine asymptotes, we need to give numbers, or we need to approach numbers from either left or right side of it. And very often, when we are describing numbers that are close to a specific number, for example, 3 plus or 3 minus, the symbols plus and minus can be very confusing. Because whenever we see a plus, we think of positive. Whenever we see minus, we think of negative. But we're going to say that positive and negative have their power, or have a stronger meaning when they are in front of the number. When the positive and the negative are in the exponent, they don't necessarily mean positive or negative number. It means slightly bigger, slightly smaller. Okay? So I'm going to write here, A is a number. So the plus in here means slightly bigger than A or greater than A. Let's use a fancier word. Sorry. And when we say A minus, it means slightly smaller than A. So let's take a look and see how they work with real numbers. So I took as examples some positive and some negative numbers. So I'm going to get started with 3 plus. So here's the number line. And I'm going to place 0 in the center. And I'm going to scale it. And here is number 3. And I will say that 3 plus numbers will be to the right of number 3. An example of a number to the right of 3, very close to it, will be 3.00001. Now here's 3 again. And this time, we want to actually take the example of a number to the left of 3. To the left of 3 means that the number would be very close to 3 on the left-hand side, so it would be slightly less than 3, so 2.99999. You can add as many 9s as you wish. So as you can see in here, 3 plus is a positive number, and so is 3 minus a positive number. So the minus in the exponent spot doesn't mean that the number is negative. Okay, so it's a very important thing to emphasize and to learn. Okay, and remember. Now let's take a look at negative 3. So here is negative 3. Here are all the numbers to the right of negative 3. So we say close to negative 3 to the right side of it. So that's why the plus is in there. So as you can see in here, if you were to choose a number to the right of negative 3, then you would say an example would be negative 2.99999. So always try to visualize things, not memorize them. Not just memorize them. Some people are good at memorizing, but the more substantial learning happens when we really understand the why when the things are happening. Okay, so negative 3 from the left-hand side, though, imagine that the number will be beyond negative 3 in the negatives, would be negative 3.00001, right? So it's a slightly different scenario, or I would say the opposite when it comes to the positives. So 3 plus, so positive 3 plus is 3 point something, but negative 3 plus is negative 2.99999, right? So what I'm trying to emphasize here and what I want us to get from this exercise is that, again, the plus or the minus in the exponent spot here doesn't mean that the number is necessarily positive or negative. Now, only for one number, number 0, when we say 0 plus is a positive and when we say 0 minus is a negative. And that is because 0 is a neutral number, right? So when we are to the right of 0, we are in the positives. When we are to the left of 0, we are in the negatives. So to the right of 0, we have 0.000001 positive. To the left, we'll have negative 0.00001, right?